Got a call.
Oh,
It's a scam.
did it already hang up?
I don't know, but it's not. Now the video's going.
Okay, well that means another whole new file. So this is going to be a 5-part video series here for today's class. Okay. I always need to put it on Do Not Disturb, and I always forget. Okay, so it goes up to here. Now this is what we refer to as an excited state, a higher energy state. Well, in nature, everything wants to be in the lowest possible energy state, not the highest. Lower energy always means more stability. So the electron's going to come back down just naturally. You have to force it to go up by putting electricity into it or heat, but it comes back down all on its own. So there are a bunch of different ways it can come back down. It can go all the way 7 to 1. It can go 7 to 6, 6 to 1. It can go 7 to 5, 5 to 1. It can go 7 to 4, 4 to 1, 7 to 3, 3 to 1, 7 to 2, 2 to 1. Or it could go 7 to 2, 2 to 1, 6 to 2, 2 to 1, 5 to 2, 4 to 2, 3 to 2, and then down. Or, you know, we have all of these different possibilities. That's every single possibility of an electron transition. There's 21 different possibilities. Okay? But we want to know why the glasses. Put the glasses on now, okay? And look at the light, and you see a plethora of rainbows, okay? The rainbow is red, orange, yellow, green, blue, indigo, violet, all of the colors blending into one another. It is what we refer to as a continuous spectrum, okay? So white light is a mixture of really infinite numbers of colors of light all just being mixed together. Now, put the glasses on, okay? I'm going to turn the lights off. This is what Bohr was looking at. If you look at the hydrogen spectrum now through those glasses, and if you want to, you can get out and get closer, okay? You should be able to see a very distinct red line. Then out, when you're looking out to the side, then you should see a teal colored line. Then you should be able to see a violet line. Are we seeing that?
Oh, yes.
Okay, so technically there's 4 lines in the visible light spectrum. There is a second violet line, but it's right on the very edge of the visible light spectrum, what our eyes can pick up. And in this room with all the stray light and with the very expensive, you know, firework glasses that you have on. Okay, I'm right in the middle of the video, so hush. Okay, we can't see that violet light. Okay, we can only see 3 of the 4, but there's really 4 in the visible light spectrum. And what it turns out is that Bohr was able to figure out that this is the red, that whenever an electron transitions from the third to the second, that's when it gives off the photon that we perceive as red on that line. This is the teal colored one. This is the first violet one. This is the one we can't quite see violet. And then this 5th one is barely into the ultraviolet region, so our eyes can't see it either. Okay? And when we come back from the break, we'll talk about exactly how did he calculate this and look at the math behind it. Okay? So go ahead and stop it again.